All right, guys, here we go. So these are contextual questions. They're giving us rates of change, and we're going to be adding them up by finding area under the curve. You'll see what we mean. So let's read this question, guys. This is from the 2015 AP exam. This is question number 1. So it says the rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t is equal to 20 sine t squared over 35 cubic feet per hour. T is measured in hours between 0 and 8. The pipe is partially blocked, allowing water to drain out at the other end of the pipe at a rate modeled by d of t cubic feet per hour between 0 and 8. There are 30 cubic feet of water in the pipe at t equals 0. Okay, do we understand what's going on? There's water going into a pipe and there's water going out of the pipe. We got that, guys? And these are rates of change. These are flows, say in cubic feet per hour. So I'm going to go ahead and write what's what. This one is in. This one is out. The initial amount, and I guess I'll write the word initial. Initial. The initial amount of water is 30 cubic feet per water. I don't know. Maybe we use W. Are we still okay, guys? All right, let's see what letter A says. How many cubic feet of rainwater flow into the pipe during the 8-hour time interval between 0 and 8? All right, they just want to know how much water went in. That's pretty simple. All you got to do is find the area under the curve of R of t. Chop, how do you know that so fast? You let the units help you out, guys. Let the units help you out. Cubic feet per hour times hours is just cubic feet of water. Do you guys see that? So I'm going to go integral from 0 to 8, because it says during the 8-hour time interval, 0 to 8, of what? Of R of t, capital R, and then put dt. Do you have to do anything by hand? No, this is called a setup. Everything is done with a calculator. Do not show the antiderivative, just show the answer. So take your calculator, and I'm going to type this into y1. I'm just using this for illustration purposes. Put that in y1, put the out in y2. So I'm going to put the in y1, so let me click in, y1, 20 sine, let me clear everything, clear, 20 sine alpha y equals, because I want it to look like it looks in there, and I'm going to say t squared over 35, x squared over 35. I click close, and I'm going to go ahead and put the y2 for now, guys, because I know I'm going to need it eventually. Negative 0.004 t cubed, negative 0.04 x cubed, go down, plus 0.4 t squared, plus 0.4 x squared, and plus 0.96 t, plus 0.96 x. All right, I have y1 and y2. Here we go. I don't need the y2 yet, but I'm sure I'm going to need it eventually. I'm going to go math 9, 0 to 8. I have r of t and y1, so alpha trace y1, and I'm going to put an x here, and I'm going to push enter, and then 76 point, how many digits do I need after the decimal? 3, at least 3. 570, so 76.570, and if there's units, put units. Cubic feet. They tell you in the stem of the problem anyways that that's cubic feet, but put it in there. Cool, yeah.
If it's 570, what's up to there?
I would. I think technically you're clear. You're in the clear. But I would always. Heck, I might even just put more digits. All right, letter B. Is the amount of water in the pipe increasing or decreasing at t equals 3 hours? Give a reason for your answer. Okay. Correct math is correct math. Don't freak out. Just think about it. Just think about it, guys. You already have a rate of going in and you have a rate going out. If R of t, if the amount of water going in is larger than the amount of water going out, the water is. If the amount of water going out is larger than the amount of water going in, the water is. Does that make sense? So all you have to do is compare the rate going in versus the rate going out. Cool or not cool? Okay, so I'm going to go R of 3, that's the amount going in, and I'm going to subtract D of 3, that's the amount going out, and I'm going to see what that number is. If it's positive, it's increasing. If it's negative, it is decreasing. You don't have to do anything, guys. Look, here it is. Here's the calculator. Do not use calculator notation. I got to keep warning you. Don't use calculator notation. So this right here is correct. Now give me the answer. How do you give the answer? Guys, work smarter. You already have the equations in your calculator. Just do this. Go alpha trace y1. That's your rate in, right? Open a parenthesis and put 3. So it's going to calculate the amount going in at 3, and I'm going to go subtract the amount going out. So alpha trace y2, push enter, and put 3. Chav, is this the only way to do it? No, there's other ways. There it is, negative 0.3136. Negative 0.3136. So I'm going to say, I'm going to use the stem to help me out. The amount of water in the pipe is decreasing, and you got to give a reason why. Decreasing at time t equals 3, at t equals 3, since what? R of 3 minus D of 3 is negative. That's how you say negative. And there it is, full credit. If you don't like that route, guys, this is probably the most accepted answer like this. I don't know. I haven't looked at the rubric. But I would take a guess that this is probably be the most accepted answer. The other second most accepted answer, I would take a guess, is probably like you figure out what R of 3 is, you figure out what D of 3 is separately, and maybe you go like, oh, D of 3 is larger than R of 3, hence there's more water leaving than coming in, hence it's decreasing. That's probably the second best answer, but I think the one in red is probably the most accepted answer. Are we feeling okay, guys? Anything crazy right now? Okay, next one. At what time between 0 and 8 is the amount of water in the pipe at a minimum? Justify your answer. Okay. There's many ways to do this. The easiest way, the easiest justification in my opinion, is to test your endpoints and critical points. And just make a table of those, and whichever one's the smallest is the absolute minimum. Chop, what are you talking about? Okay. I'm going to say T, and I'm going to say W of T. That means the amount of water. I'm going to put 0, and I'm going to make some space. I don't know what my critical numbers are, but I'm going to find them. All right, the amount of water is equal to, because they want to know the amount of water, right? How much water did I have initially? 30, so I'm going to say 30 plus the integral of your net change. So the integral from 0 to t of R of t minus D of t dt. Chop, I don't understand what you're doing. Remember, guys, when we integrate this, R of t minus D of t, that tells me how much water is in there. You could have done 2 separate integrals. The amount of water that flowed into the pipe, and then subtract the amount of water that flowed out of the pipe. You could have done both. But integral properties, are you guys okay with that? Okay. What's up? Mejia, ask me. Okay. All right. I'm going to get critical numbers. How do I get that? I'm going to set the derivative equal to 0. So W prime of t equal to 0 to get my critical numbers. So you're only going to get 1. So fundamental theorem of calculus part 1, you're just going to do where R of t minus D of t equals 0. See, when you take a derivative, that's a constant. When you take the derivative of this integral, you just get the inside. Those are kind of like, I know yesterday with Hernandez and Moreno, we talked about like how these are like already derivatives because they're rates of change. So some of you might be thinking like, well, it's already a derivative. Well, then look, there it is, R of t minus D of t. The whole thing. You could also say where R of t equals D of t, but I think it's easier like this. So you guys ready? I already have my calculator. It's already, look, R of t and D of t already in here. I'm going to turn it off. I'm going to turn off Y1. And I'm going to turn off Y2. Chop, why are you doing that? Because I want to do Y1 minus Y2. You could also leave Y1 and Y2 on and see where they intersect. But it's easier to do this. So I'm going to go alpha trace Y1 minus alpha trace Y2. There it is. I'm just going to graph that. Before you push graph, push window. You're only searching between what and what? 0 and 8. And we're going to hover around the x-axis. So I'm going to say -1 to 1. And I'm going to push graph. There's only one. Think about it, guys. Okay, Tom, I don't understand what you're doing. I have no. All right. What I just graphed right now, this is the net rate of change. In minus out. So initially, there is more water coming out. More water coming out until right here. At that moment, that's when I have the least amount of water in the pipe. And then after I pass that moment, there's more water coming in than out. Do you guys see that? So that's obviously where my absolute min is going to happen. But here it is. You don't have to do any thinking. You can just do a table. So here it is. Watch. Second, calculate number 2, 0. And it says left bound, 1, 2, 3. I'm going to push 3, enter. Right bound, I'm going to push 4, enter. See, I'm looking between 3 and 4. Guess, and just push enter. And there it is. 3.2716584. So I'm going to say this happens at t equals, and I already forgot it, 3.27, 16584. 16584. All right, that's what I'm going to put in here. 3.2716584. And then 8. All right, I'm done. Here's my answer. 30. I know that 3.27 is going to be a smaller number, so I go to my calculator. Second quit. I'm going to store that in A, so I'm going to go X store alpha A, so I can use the letter A. And here we go. 30 plus math 9 from 0 to A of Y3. You can say Y1 minus Y2, but I have it in Y3, guys. Sorry about that little hiccup. Enter. I'm not shocked that it's smaller. It has to be smaller. 27.9645. I haven't looked at the rubric yet, guys. We'll look at the rubric in a little bit. 27.9645. 9645. And then just for kicks, you don't need the 8, but I'm gonna find it anyways. It's gonna be a larger number than all three of them. 8. 48.5436. 48.5436. This is your justification. You found your critical number. And then I'm just going to write. At what time? At t equals 3.27165. The more digits, the better. The amount of H2O in the pipe. You can also say HOH, right? 2 oxygens, 1 hydrogen. In the pipe is a minimum with 27.9645 cubic feet of water. There it is. Full disclosure, I have not looked at this rubric yet. Of course, I did last year, right? But I haven't looked at it since, so I have I can't remember what the details of. My memory is not good enough to remember rubrics from last year. We'll see how they wrote it. Letter D. The pipe can hold 50 cubic feet of water before overflowing. Okay. For t greater than 8, water continues to flow in and out of the pipe at the given rates until the pipe begins to overflow. Got it. Write, but do not solve an equation involving one or more integrals that give the time W. So time W. Time equals W. When the pipe will begin to overflow. Okay. Let's see. So W, amount of water. So 50 equals, so how much water is in the pipe? So 30. Can I say the same thing? 30 plus, yeah, I think I can. 30 plus integral from 0 to W of R of t minus D of t dt. I think we got it right. The pipe can hold 50 cubic feet of water before from the water continues to flow until Given rates it's being overflow, right? But they're not solving an equation involving one or more integrals that give the time W when the pipe will begin to overflow. Yep, I think it is how much water is in the pipe. This tells you how much water is in the pipe. So it begins to overflow once I reach that. Right, but they're not solved. Do I need an equality? No, because that's how much water can hold. Let's look at the rubric. Let's see how it looks, guys. What year was this? 2015. All right, I have them all. Math life. How many points per free response question, guys? 9. What's a good score? I would say 5. If you want a 5, I would say you got to be getting 6, 7 points consistently. If you want a 4, I would say 4 or 5 points is good. 3, I think 4 points. 4 points. All right, free response, A/B, scoring guidelines. What do you think? Want to know? What do you think of this question? Did you like it? Did all that make sense? Or are you just telling me that just to? Yeah. All right, here it is. Let's see how they broke it down. Yeah, these are usually always 2 points. Look at this, guys. Letter A, how many points? 2. 1 point for the integral, 1 point for the answer. They didn't even bother writing the equation. They just wrote R of T. That's what I want you guys to do. Yeah, sometimes they do. Okay, look, but they accepted both answers, which they have to, right? They're both the same. R of 3 minus D of 3 is negative. Since D of 3 is greater than R of 3, the amount of water in the pipe is decreasing at time t equals 3 hours. I love it. That was worth 2 points. Letter C, yeah, there it is. 30 plus. So here they did the same thing we did. You don't necessarily have to show the A. You can say max or you can say not applicable, but make sure. I would just, to play it safe, I would just fill in all of those. Critical numbers and endpoints for minimum. The amount of water in the pipe is the minimum at time t equals 3.272 or 271. Did they want the amount of water 27? I guess they didn't. The amount of water in the pipe at t. They just wanted the time. All right, and then letter D. Yeah, letter D is going to look the same for everyone, pretty much, because that's how much water the pipe can hold. The only other way that I can think that it would be different is if you do 2 integrals instead of 1. Plus the how much is in minus an integral of how much goes out. Other than that, they're all going to look the same. What you guys think? No, for real, guys, what you guys think? These are real response questions. This is how your exam's going to look. You're going to have at least one of these. Do you think we have enough time to do one more? Okay, here we go, guys. Question 2. I know that we're tired. It's the end of the week. Hopefully, I know we're on, running on fumes here, but let's see if we can finish strong. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by. So this is remove. So this is out. Where F of T is measured in pounds per hour and T is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by. So this is in. You could also say add and subtract, whatever. Where G of T is measured in pounds per hour and T is the number of hours after the store opened. Okay. Letter A. How many pounds of bananas are removed from the display table during the first 2 hours the store is open? So that's the out one. And if you let the see how it says pounds of bananas? So let the units help you out. Pounds per hour times hours is going to be pounds. So we're going to find the area under the curve. The area under the curve of which curve? The F of T. So from 0 to 2, the first 2 hours of F of T dt. You don't have to do anything by hand. I would type this guy into y1 and I would type this guy into y2. So take your calculator. Uh-oh, what's this? It is recording, right? Yeah, it's recording. Dude, can you hook me up with what I have in there, guys? It was 10 plus. Hook me up with it, Pina?
10 plus parentheses 0.8x. Sine. Cubed on top of 100.
Like that?
Yes. Close.
And what was y2?
3 plus 2.4 ln t squared plus 2t.
Like that? All right, here we go, guys. Math. Oh, second quit. Math number 9, 0 to 2. And alpha trace y1, and I'm going to push x here, and I'll push my enter, and there it is, 20.0511. 20.0511. And I need units, pounds. Cool or not cool? All right, letter B. Find f prime of 7 using correct units. Explain the meaning. Oh, man. Explain the meaning of what that means, I'm sure. I guess I just didn't finish typing it. I'll look at the rig in a little minute. Just explain the meaning. I'm pretty sure there was... All right, here we go. F prime of 7. You don't have to show anything, guys. You do not have to do the derivative by hand. You just tell me what f prime of 7 is. So you're going to go math. You're going to go number 8, numeric derivative, x in here, and then you're going to go alpha trace y1, and you're going to put at x equals 7, and then enter. And there it is, negative 8.119539. Negative 8.11, what? 1195398. 1195398. And I need units, pounds per hour. So let's describe it in context, what it means. So let's see. When a certain store opens and has 50 pounds of bananas displayed, customers remove bananas from the display table at a rate modeled by. So the rate is decreasing by 8.1195 pounds per hour. Does that make sense? On the right. The rate at which bananas are being removed is decreasing. The rate at which bananas are being removed, so we're talking specifically about the rate of bananas. The rate at which bananas are being removed is decreasing by 8.1195 pounds per hour. Pounds per hour. You can do pounds per hour / hour. Dude, are we continuing? Yes. Letter C. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Well, either. I know there's some of you that I saw earlier that were doing it. You just compared f of 5 and g of 5. That's perfectly great. You can do that. But I'm telling you, usually by habit, they like to find like what is an equation for the net change. And that is the amount going in minus the amount going out. Does that make sense? So I'm going to go g of 5, that's the amount going in, minus f of 5, the amount going out. If this number is positive, the amount of bananas is increasing on the display table. If this number is negative, the amount of bananas is decreasing. Does that make sense? So remember, I already have these equations in my calculator, guys. This one's in the y2, this one's in the y1. So this is all you got to show, just g of 5 minus f of 5, because it's a calculator portion. And here it is. I'm going to go second quit. I'm going to go, let me clear everything, guys. I'm going to go alpha trace. I'm going to click y2. I'm going to put a 5 in here. I'm going to go minus alpha trace. I'm going to put y1. I'm going to put 5 in there. I'm going to push enter. And there it is. Negative 2.2631. Negative 2.2631. And I'm going to say the bananas on the display table are decreasing. The bananas on the display table are decreasing at t equals 5 since g of 5 minus f of 5 is negative. That's how you say negative. And I already said that it's negative at 5 because I included g of 5 minus f of 5, and there it is. The bananas on the display table are decreasing at t equals 5 since g of 5 minus f of 5 is negative. Does that make sense, guys? All right, last one. How many pounds of bananas are on the display table at t equals 8? Okay, so the amount of bananas on the display table is the initial amount. What was the initial amount? 50, so put 50. Plus how many I've been adding. So how many bananas have I been adding? The g of t, so I have to go integral of g of t from what to what? From what? No, not 0 to 8. Look where g of t starts. 3. 3 to 8. And I got to subtract the bananas that have been removed, which is from what to what? That one is 0 to 8 of f of t. Type it in your calculator carefully. So here's my calculator. I'm going to go 50 plus math 9. I have this one, let's see, 3 to 8. I have this one in y2. So I'm going to put alpha trace y2 minus math 9, 0 to 8 of y1. And there it is, 23.34739. 23.347. 23.347 pounds. What do you guys think? Cool or not cool? Do you guys want to see the rubric, or are you guys okay with this one? Okay. Let's go to the next one. We'll see the rubric for this one, guys. From the 2004 Form B, question 2. Between 0 and 31, the rate of change of the number of mosquitoes on tropical island at time t days is modeled by blank mosquitoes per day, whatever that is. RT equals 5 squared of t equals nt over 5 mosquitoes per day. There are 1,000 mosquitoes on the tropical island at t equals 0. Okay. Show that the number of mosquitoes is increasing at t equals 6. Okay, guys, type this into your y1. So 5 squared of t cosine of t over 5. I think I can remember that. Second memory 712. 5 square root of t. 5 square root of x cosine x over 5. Yeah, I couldn't remember it. Short-term memory. It's bad right now. All right. There it is. I got it in y1. And letter A. Show that the number of mosquitoes is increasing at t equals 2. All right. What do? Do I take a derivative? Do I just plug it in? Or what did I do, guys? Yeah, this is already a rate. This is R of t is already a rate, guys. So it's like a quote-unquote derivative. It's not, right? It's expressed as R of t. That's a rate. Plug in the 6 in there. If it's positive, the number of mosquitoes is increasing. If it's negative, the number of mosquitoes is decreasing. So let's find out. So I just go to my home screen, and I'm going to go alpha trace y1 at what value? Yeah. You could have also looked at a table. It doesn't matter how you do it. 4.4379. So I'm going to write R of 6 equals 4.4379. And I'm going to say semicolon. And I'm going to go since R of 6 is positive. That's how you say positive. Comma. Number of mosquitoes is increasing. Number of mosquitoes is increasing at t equals 6. Done. Since R of 6 is positive, number of mosquitoes is increasing at t equals 6. Does that make sense, guys? All right. Letter B. Look, you could have let letter B help you to get letter A if you would have said that it's decreasing. At time t equals 6, is the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? Give a reason for your answer. So if you said, this is timeout, guys. If you said that the number of mosquitoes was decreasing on letter A, oh, okay, you know what? They won't let you because they told you to show that the number is increasing. So never mind. But letter B would have given you a big hint that, look, it's positive. R of 6 is positive. All right. So how do I know if it's increasing at an increasing rate or increasing at a decreasing rate? Yeah, that one is derivative. It wants to know, is that R prime? If R prime is positive, I'm increasing at an increasing rate. That means that you have a graph like that, concave up. If R prime is negative, I'm increasing at a decreasing rate like that, concave down. Does that make sense, guys? All right, so here we go. I'm going to go R prime. You don't have to show anything else. Some of you, I remember when you took your mock exam number 1, you showed all the rules for the derivative. Guys, if it's a calculator, just go R prime of 6 and just show that answer. You don't have to do anything else. So here it is. Ready, Chavez Dua? What do I do? How do I get the derivative in here? Math. 8. Perfect. I put an X in there. I go alpha trace Y1. And I'm going to put it at what value? Yep. And I push enter. And what did I get? Negative 1.9131 or 32. Let's see. Negative 1.9131 or 32. And here we go. I'm going to say semicolon. I'm going to go, the number of mosquitoes is increasing at the number of mosquitoes, let me move this here, of mosquitoes is increasing at a decreasing rate since R prime of 6 is negative. At t equals 6. Oh, that's fine. The number of mosquitoes is increasing at a decreasing rate at t equals 6. I would probably add that in there. Since R prime of 6 is negative. Done. Full credit. Cool or not cool? All right, we're almost done, guys. According to the model, how many mosquitoes will be on the island at time t equals 31? Round your answers to the nearest whole number. Okay, here we go. How many mosquitoes were there initially? 1,000. Number of mosquitoes equals 1,000 plus, and then you got to add up how many mosquitoes have either gone in or gone out. And I have that rate, my net rate. So I'm going to put integral from what time to what time? Oh, man. Yeah, 0 to 31. And I just plug in R of t right here, dt. Okay. And that's it. Put it in your calculator. So let's see, 1,000 plus that. So 1,000 plus math 9, 0 to 31, alpha trace, y1, x, enter. Ooh, it's thinking hard. 964.335. Did yours take a long time? No? It took a long time? Mosquitoes. Okay, they did say to what? So 964 mosquitoes. If you leave it 964.335, you're going to miss the answer point, probably. All right. To the nearest whole number, what is the maximum number of mosquitoes between 0 and 31? Show the analysis that leads to your answer. Guys, I would always do a table for these. Not always. I saw the rubric earlier. They didn't do a table. But I would do a table, T and the number of mosquitoes. And all I would put on that table is my critical numbers and the endpoints. So 0, 1,000. There's 1,000. And then I know there's 2 critical numbers. If you don't know that, leave that. Leave a space, significant space there. 31. There's 964. Okay. Chop, how do you find your critical numbers? Well, all right. Focus, Pina. Don't worry. I know you did it earlier, but oh wait, no, you didn't do this one earlier. All right. Number of mosquitoes. Let's get an equation. Let the top one help you out. Let this help you out. 1,000 plus integral from 0. You're not going to put a 31 up there. You're going to put the letter T. You want to figure out that number. Bless you. R of t dt. Child, there's a t there and a t there. Okay, fine. Make that r of x dx. It does not matter. It does not matter. Physics does it all the time. They put those t's and x's all together. This will tell me my number of mosquitoes no matter what. Yay or nay? Fundamental theorem of calculus. If this is what I want to find the max of, this is what I take a derivative of. I take a derivative and look what happens. I'm going to put take dir to find critical. To find critical. Look at this, guys. R of t equals 0. I took my derivative and I equal it to 0. I know what you're thinking. Chop, couldn't I have just written R of t equals 0 because R of t is my rate anyways? Whenever the derivative... Okay, Chop, what are you talking about? when the derivative, remember, we said R of t is like a derivative anyways. You guys remember that? Because it's a rate. When the derivative goes from positive to negative, I have a max. When the derivative goes from negative to positive, I have a min. So you didn't have to do this top line. That's just, notice that fundamental theorem of calculus guarantees that we're still doing R of t equals 0. Look, I took a dir. What did I take a dir of? I took a derivative of this, fundamental theorem of calculus. The derivative of 1,000 is 0. The derivative of this guy is just R of t. Oh, look, I would have found it anyways with fundamental theorem of calculus. Did you have to do this front line, this top line? No, you could have just gone right into, oh, this is my rate. If I want to find my maximum, wherever R of t is 0, find critical numbers, or wherever R of t changes from positive to negative, and I know I have a max. So I take my calculator. I already have it in Y1. Yeah, this one was tough, guys. I probably shouldn't have put it in here for rookies. Maybe I should have put this one in towards the end. But if you get it, then you're way ahead of the curve. I'm going to click on window. I'm going to go to 0 to 31 because that's the only window I care about. And then I'm going to hover around the x-axis. Negative 5 to 5 is fine. Negative 1 to 1 is fine. Graph. Check it out. I have a maximum right here. I have a minimum right there. I do not care about the minimum, but I do care about the critical number because that might be worth a point there, maybe. So here we go. Second, calculate number 2. I want a 0 between 1, 2, 3, 4, 5. I'm going to play 5, 6, 7, 8, 9, and 9. See, so guess between those two, enter. There it is, 7.85. That's where I have my max. I'm going to go over here in the home screen, and I'm going to go X store alpha A. 7.8539. So I'm going to come over here. 7.8539. Put as many digits as possible. And yeah, we're good. Let me find the other one, guys, because I'm going to need it. Well, actually, no, I don't need it, but I want to put it down here. So graph. Second, calculate number 2 again. And then I'm going to look between 15 and 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Guess, boom. 23.561945. 23. I don't care about that one, but I wanted to put it in here. 23 point what? 5649. And I'm going to put NA, not applicable. This one is a min. That way I don't have to give the answer because I know there is a minimum. I just care about that one. All right, so let's see how many mosquitoes there are. I will go to my home screen. 5619. Did I write that? 5619. You guys didn't tell me. What I got it? Maybe a point off. All right. My home screen. Second quit. Here we go, guys. 1,000 plus math 9 from 0 to A. I already stored it in A. Alpha A of Y1. Alpha trace Y1 dx. Push graph. Push enter. 1,039.3569. 1,039.3569. And they did say to round to the nearest whole number. So I'm going to, what is the maximum number of mosquitoes? Show the analysis. Okay. They just want to know the maximum number of mosquitoes. Max number of mosquitoes on this specific interval is 1,039 mosquitoes at t equals 7.8539 hours or days. I'm going to erase the units. They don't need that. All right, let's look at this rubric and we'll call it a day. Let's see. 2000. What year was that? 2004. 4B. Got it. Thank you, miss. 2004. All right, here it is. Let's see how we did. It's this one right here. They just gave us 1 point for letter A. Since R of 6 is 4.438, which is positive, the number of mosquitoes is increasing at T equals 6. We got it. Letter B. Did we get negative 1.913? Yep. Since R prime of 6 is negative, the number of mosquitoes is increasing at a decreasing rate. Perfect. We got it. Letter C. They gave us 2 points, one for the integral, one for the answer. We got them to the nearest whole number. There are 964 mosquitoes. If you left it as 964.335, you probably did not get the answer point. I wasn't there at that reading. I was still a high school kid. Actually, no. I was a freshman at the university. All right. Next question. Letter D. Chop, what is all this? We didn't write it like that. Relax. All this is saying is I got my critical numbers. 2.5 pi is that decimal that we got. I didn't know it was a perfect with a pi. And that the other one is a 7.55. R prime of t is positive between 0 and 2.5 pi. Yep. R prime of t is negative between 2.5 and 7.5. R t is positive. Guys, relax. We got it. We got full credit with the table that we did. All this is saying is just this. It's saying this. That RT is positive between here and here. It's negative between here and here. And positive between there and there. The maximum must occur here at this endpoint because we already know the maximum of 31 is 964. That's what that is saying. But a table is perfect, I think. A table would have been perfect. So I don't know why they didn't do a table, but that's fine. And there it is, 1,039. There are 964 mosquitoes that equals 31, so the maximum number of mosquitoes is 1,039 to the nearest whole number. What do you guys think? Cool or not cool? All right, guys, we're done. Good job. You guys were good sports. I appreciate you guys.
I appreciate you, Sean.
Bless you.